Good morning. So I'm just going to continue with the topic of linked list. As you remember from last time, we saw arrays before, and one of the problems with the arrays is that, first of all, we need to know the size, and the size is fixed. So let's say like you want to store a bunch of numbers that you don't know exactly what the size is. What you have to do is basically allocate a huge array, and you might not be using the whole array, you might be using only a portion of it. Well, the solution for that would be using dynamic arrays when we can have a user-defined size. But again, that size is going to be fixed. So if you want to add an element to your array, the problem would be just like, again, existing. So you have to basically deallocate, allocate a bigger array. Or another problem is if, let's say, like you want to insert something between two elements of your array. How you can do it, again, it's not going to be that easy. You have to do a deallocation, allocation, or shifting elements. So for applications where you need to insert or delete elements from your data structure very frequently, a better solution is linked list, right? So we can use linked list. What linked list is basically a dynamic data structure that we can define it using either a struct or class. We would have some nodes that this node or this class would have two parts. One part would be the data that you want to store in this structure, and it would have, for now we're talking about the singly linked linked list. So it would have just one pointer. The pointer, it's going to be of the same data type. So it means that it points to another node. Let me just call it pointer, or we can call it link or next, or based on the application. We just try to give it a meaningful name. So basically what linked list would end up being would be bunch of nodes that has two parts. One part would be data, and the other part, let's call it link. So what we end up doing is we link the nodes together. So we make this node to point to this node. We made this pointer to point to this node. We made this pointer, the pointer part of the node, to point to this node, right? And this is how we end up with a linked list. Now, if you see here, there is one problem. So how do we know that the list starts? So we always have to have a head pointer that points to the first node of our list, right? So this is called the head of the linked list. This is the tail of the linked list. And again, if we traverse through the linked list, how do we know where the linked list ends? So by filling the last pointer of the pointer of the last node with the null pointer, or sometimes they show it like this, we know that this is going to be the last node of the linked list. Okay, so this is how you can basically create a linked list, and these nodes are dynamic, so we allocate and deallocate them easily. In this case, if you want to, for example, delete, like here, like you can store the data, for example, 1, 3, 5, 7. And if you want to delete this one, it's very easy. You just like have to make this pointer to point to the next element and delete this one, right? And that easily, this is gone. So you end up with this. And now, let's say like you want to insert a node now with the new data. Again, that's going to be easy. So first of all, let's say you create a dynamic node. You fill it with the data that you want to insert, let's say 6, right? And now what you have to do, make this pointer point to this one, and then make this pointer point to this one, and this is going to be gone. So inserting and deleting becomes much easier in linked list. What is the problem with the linked list? Can you guys guess what the problem with the linked list is and what was the advantage of array or vector? In arrays and vectors, we had index. So we could easily access to, let's say, element AI of the array. However, in the linked list, how can we do that? We have to traverse all the way from the beginning, from the head, all the way to the tail to find, for example, the elements that we need. So we don't have random access in the linked list. We have to traverse through the linked list to find the node that we need. So this is all just an introduction about linked list. Now, what we're gonna see today is just gonna be some of the algorithms that we can use with linked lists. I'm not gonna implement them. I'm just gonna try to analyze them here. Okay, the implementations is in the PowerPoint file that is posted on the canvas, but here I just want to analyze them. First of all, I want to do a code analysis question. So I want to write a code and I want to ask you to analyze it. Let me bring another. So let's call it move. I want you to get familiar with analyzing codes. At the same time, I want you to get familiar, if you forgot about pointers, I want you to get more, review some of the concepts of the pointers.